Hello, my name is Agastishwar P. from Mechanical Engineering, register number 2020509005. This video is a part of the subject Industrial Training and Internship ME5513. Here I am going to talk about one of the working station of a steel plant. This is the product processing flowchart of a steel plant. There are various workstation and furnace present in steel plant where the raw materials such as coking coal, iron ore, fluxes are processed step by step in each workstation and finally produce the required grade of steel stated by the customer. In this video, we are going to focus on one of the important workstation, that is the steel melting station. The steel melting station consists of the energy optimization furnace, the lading heating furnace, the vacuum degassing machine, and continuous casting machine. SMS, the steel melting shop or station. The steel melting shop receives hot metal from the iron making unit, that is the blast furnace, and converts it into various grades of steel and casts them into blooms, billets, beam blanks, rounds, and thin slab heat roll coils. SMS is the first stage in the steel manufacturing value chain where the product is differentiated and customized. The steel melting shop has following units and auxiliary departments. Those are EOF, Energy Optimization Furnace, LRF, Ladle Refining Furnace, VD, Vacuum Degassing, CCM, Continuous Casting Machine. EOF, Energy Optimization Furnace. This is the first and foremost unit of the steel melting station. The energy optimizing furnace is an oxygen-based melting and refining process for the manufacturing of liquid steel that starts with hot metal and uses up to 40% preheated scrap. This unique scrap preheating process has a 25-year history of success. The EOF works with combined oxygen in an initial stage blown into the furnace containing the hot metal, where the preheated of the scrap takes place and the fluxes are sent inside for the slag formation. These are the images of the energy optimizing furnace. As we can see here, the ladle from the blast furnace containing the liquid metal is poured inside the EOF, where the scraps are present. As the heat from this liquid metal preheats the scraps, or where the 40% of the heating is done. After this, the scraps are melted and the customization and the differentiation of the steel of the required grade stated by the customer is done. The cross-sectional view of the energy optimizing furnace is presented here. With reference to this, the basic features and dimension of the energy optimizing furnace are going to be discussed. The hard surface is in the range of 6.6 square meter to the 22 square meter. The shell diameter is in range of 5.3 meter to 7.5 meter. This is the shell diameter. The total height from working platform to the top level is around 17 meter to 25 meter. The tilting angle for taping and deslagging is up to 8 degrees. The angle of taping and deslagging is done here in this part of the furnace. After tapping steel from the primary steel making furnace, that is the energy optimizing furnace, the molten steel is further refined in a variety of alternating process known as ladle refining. This is done in the ladle refining furnace. Here, the argon and nitrogen gases are pumped inside the furnace where the carbon monoxide air bubbles which are present in the liquid steel are removed. By this, the high grades of steel are produced by doing this process. This is the image of the ladle refining furnace from a steel plant, where these three electrodes produce the optimum heat required in this process. The next stage is the vacuum degassing. Here, the vacuum degassing machine uses a unique technique of removing dissolved gas from a solid solution by lowering the pressure inside a vessel containing the liquid steel. It is typically a vacuum chamber where the air inside the chamber are pumped out. Here also, a pipeline to produce the argon air is present for the refining of the liquid steel. The two major process parameters followed here are the flow rate of the liquid and the pressure maintained inside in the chamber. The final machine of the steel melting station is the continuous casting machine. Here, the continuous casting process of producing an infinite solid strand from liquid steel by continuously solidifying it as it moves through the continuous casting machine. The basic operation of the continuous casting machine is to convert the liquid steel of a given composition into a strand of desired shape and size through a group of operations. As we can see here, the ladle is present here where the liquid steel is present. Here, from the tapping area, the liquid is flown and it is flown through the mold where the solidification is take place. Here, there will be a series of water cooling system present where the water droplets will be falling on the liquid metal which solidifies the steel. Later, it is cut using a torch at a desired dimension. This is the image of the solidified metal passing in the continuous casting machine after being cooling down by the water droplet system present in the continuous casting machine where the liquid steel is solidified into this state. In this image, we can see the function of the cutting torch, which helps to cut the uh, solidified steel into the required dimension. This is the workplace of the continuous casting machine. Types of continuous casting machine. Continuous casting machines can be a single strand machine or a multi-strand machine. The strands refers to the area where the solidified metal passes. This is the strands. In case of multi-strand CCM machines, the number of maximum strands depends on the types of machine. In case of billet casting machine, the number of maximum strands can be up to 8 numbers or even high. While in case of bloom casting machine, the number of maximum strands can be up to 6 numbers. Here, we are going to see about the different types of casters in the continuous casting machine. During the development of the continuous casting machine, several types of casters have been produced with significant difference in the design heights. This picture represents different types of casters seen in the continuous casting machine. Here, the dotted lines represents the incompletely solidified part and the straight line represents the completely solidified part. First one, the vertical caster. Here, both the incompletely solidified part and the completely solidified part lies in the vertical direction. The second one, a vertically straight mold, bent runout with straightening of the solid part. Here the incompletely solid part is seen in the vertical direction where it flows through a bent runout after the straightening of the solid part takes place. Third one is the vertically curved mold, bent runout with straightening of the partially liquid product. Here completely the incomplete solidified product and the completely solidified products happens to be in a curved path where the final product is straightened. Fourth one, curved mold with horizontal runout. Here the mold is completely curved with a horizontal runout where the incompletely solidified part is seen in the curve is sent in the curved mold and the output of the solidified product is in the straight horizontal runout. Then the next one is the curved mold with gradual straightening. Next one, as we can see here in this, the curved mold is gradually straightening as it moves. So the incompletely solidified products, as it moves gradually in this caster machine, it becomes solidified and straightening takes place. And last one is the horizontal continuous casting machine, where the complete process takes place in the horizontal direction. These are done. These different types of casters are seen because of the casting speed limited by the high mold friction and also due to the limited support of the length. There are also different characteristics seen with respect to the product quality while usage of these different types of casters, all these types of casters. These are the final products of the steel plant. This is bloom, this is billet, and this is round. The difference between the bloom and the billet is the size. The blooms are generally larger compared to the billets. These are the information gathered by me about the steel melting station during my industrial training in a steel plant. I thank you everyone for your valuable time for seeing this video. Thank you.